Quadratic functions in factored form. F at x equals a, bracket x minus r, and bracket x minus s. We're going to start out by investigating the zeros of quadratic functions of the form f at x equals ax squared plus bx. First thing we need to think about is what we mean by the intercepts of a relation. You can pause the video right now if you want and take a minute and think about what intercepts are. When you're done, unpause the video and we'll talk about it. The y-intercept of a function is the initial value, and it's the point where the function crosses the y-axis. That is, when the value of x is 0. And that applies to any function or relation regardless of whether it's quadratic, linear, whatever. The y-intercept is always the point where it crosses the y-axis. Similarly, the x-intercept, also known as a root or 0, is the point where the function crosses the x-axis, that is when the value of y is 0. The equation of a quadratic function in standard form is also important, and we need to know and recognize what we can conclude from each variable in the equation. So when we see a function in standard form, f at x is ax squared plus bx plus c, we know that it opens up if the value of a, the leading coefficient, is positive, down if the leading coefficient is negative, and we know that the initial value occurs at the point 0c, or the y-intercept, and we know it has a vertical expansion by a factor of a if a is greater than 1 or less than negative 1, and it's a compression if a is between negative 1 and 1. Consider the example that you see here. The path of a baseball can be modeled by the function h at d is negative 0.04 d squared minus 0.04 d plus 0.008, where h at d is the height of the ball above the ground in meters, and d is the horizontal distance of the ball from the player in meters. When does the ball hit the ground? Well, first we need to choose an appropriate strategy. So that means, when is h at d equal to 0? That means we're looking for the h-intercept. Okay, we forgot to highlight. H at d is the height of the ground. D is the horizontal distance in meters. Wants to know when does it hit the ground. And of course, I've over highlighted here again. So and we're looking for when. And our units are all meters. Okay, so the only thing we've learned so far is how to find out when it hits the ground using technology. And that's what we want to figure out, is there another way? And there most definitely is, and that's what the purpose of this unit is. So we're going to work on finding the x and y intercepts. So to find the x-intercept, the y-intercept is easiest because all we have to do is substitute 0 in and solve. So f at 0 is 0 squared, which is 0. For the x-intercept, again, it's pretty straightforward. For this example, we set y equal to 0. 0 is x squared. We square root both sides. We're good to go. F at x is x squared plus x. Again, find the y-intercept, set x equal to 0. 0 squared plus 0, it's still 0. For the y-intercept, for the x-intercept, we're going to set y equal to 0. Now it's a little more challenging. We're not sure how to do this, and we're going to work on that using the TI Inspires. Now, is there a faster way to always find the y-intercept of a quadratic that looks like this? Take a minute and pause the video and think about it, and then continue on. You should know the y-intercept is always going to be 0 because the constant term is 0, and we've already established previously that the c value is the initial value. If you look at it another way, because each term has an x in it, once I substitute 0 in, all I'm left with is 0. And homework. And this table needs to be completed before class.